Hey everyone, Nick Russo here. Today I want to talk about a new project I put together using serverless compute in AWS. My specific goal was to track the polls for the 2020 election coming up in November. I wanted to have a simple one web page solution that would show me the RCP or Real Clear Politics averages for the key races that I'm watching. Let's talk about how that solution works. First, a developer, namely me, had to write some Python code. We'll do a deep dive of that code in a few minutes, but let's just assume that I wrote some code that will collect all the polling averages and display them in a meaningful way. Then I take that code and I upload it to AWS Lambda. Now I said earlier that this is a serverless design, so I didn't spin up any Linux servers, I didn't create any EC2 instances, nothing like that. Lambda just runs my code on some back-end stateless compute resources, and if I want to store artifacts, I can do that with S3, which is exactly what I do here. In this particular solution, I found that the cheapest and simplest way to display this data was using a static website hosted in AWS S3. S3 is the storage service of AWS, and I already host my main website there for those who are familiar with my work. All I did was create a new site named polls.njrusmc.net, and I allowed Lambda to write objects into it. Lambda just creates an index.html file, which is the output from my Python code, and you can just view this in a web browser, and it's really simple. New polls are coming out every few hours, and especially as we get closer to November, there'll be even more polls. I'm using AWS CloudWatch to run the Lambda function once every 6 hours, which will automatically update the website without any human interaction. This is useful to capture the new polls and ensure that my website stays up to date. Let's also quickly review how the users can access this product. First, the users will open a web browser and they'll browse to polls.njrusmc.net using basic HTTP. In addition to being the name of the S3 bucket, this is also a DNS resolvable hostname. I'm using Route 53, which is the DNS service within AWS, to resolve that name, so users will get the IP address of this website, and then they'll be able to resolve the content and see the HTML. There are very few security holes with this design because it is a serverless architecture, there's no servers to break into, and the website is static. Some of you might be thinking, why did I build this project? Why don't you just go to any of the other websites that have polling information, like go to Real Clear Politics directly or go to 538? The reason I did this is I wanted a really simple, quick way to track the key races in a nonpartisan way. What I mean by that is I want to be able to go to a website, I want to see just the numbers, I want to see who's winning, I want to see by how much, and I want to see in which locations. I don't need to see fancy graphs, I don't need to see commentary, I don't need to see pollster ratings. Those are extra details that some people might enjoy, but for me, I just want to see what the polls say because they represent a snapshot in time. This solution is extremely low cost, and even though it was a little bit tricky to set up, it's a relatively simple architecture and it's highly effective to solve the problem that I was trying to solve. To put it into perspective, this solution will only cost me a few cents, most definitely less than $1, over the next 6 months. It was also a really good learning opportunity for me. 3 years ago, I set up my static website using similar techniques, except I didn't introduce Lambda functions and there was very little Python code. This time, I've written some code specifically designed for AWS Lambda as part of a serverless application, so it was a good opportunity for me to get out of my comfort zone and learn something new. Next, let's take a deep dive into the code so you can understand how the project works. Okay, I'm at my Linux dev box and I printed out all the files in the project. We'll be exploring a handful of these files as we deep dive the code, but first let's take a look at the Python packages that I installed in order to make the project work. These are typically stored in a requirements.txt file, which you can pass into pip to install all the packages inside. The first two packages are key to the project. The Real Clear Politics package is how we collect the polling data. Behind the scenes, it uses Beautiful Soup 4 and some HTTP client actions to collect the web pages from RCP and parse out all the HTML data into Python data structures. This will save us a lot of time so we don't have to scrape through all that HTML to find the key pieces of information. I'm also using Jinja 2 to create the index.html file. I found that this was the easiest way to do text templating in Python, and HTML is a good use case for using Jinja 2. This is very commonly used for network programmability, especially when you're dealing with CLI-based automation on legacy devices, just as another example. The last two packages help measure the quality of my project. They have nothing to do with AWS Lambda or the final product, but they help me maintain the code, as the linter will check any small issues, and the formatter will keep my code consistent with all my other projects. Let's open up the polls.py module to get started with the interesting stuff. At the top, we see 4 different import statements. First, I'm importing JSON. The reason I'm doing this is because this is where we're going to load in some of our basic election data. Then I import datetime because I'm going to put a timestamp on the website so that people can see when the polls were last updated. Then, from the RCP package, I'm importing the getPollData function. Again, this is going to use some HTML parsing behind the scenes to give us structured Python data to manipulate within our script. Last, I'm importing some components from the Jinja 2 package, which are going to help us create a Jinja 2 environment and allow us to render templates. I've created a global constant dictionary named colorMap. Now, the artifact from this project is 99% HTML, but I embedded a little bit of CSS into the project just for some color coding. It's often useful to color code winners of a poll by the color of their political party. In this map, we pass in a string and we get back a different string. The key represents the political party in the same format that RCP uses, and the value is a well-known CSS color. Some polls don't have a party at all, for example, the direction of the country, the presidential approval, etc. For those, we'll just leave the color as black. I've defined a function named getRCPAverages, and this is where the heavy lifting takes place. It takes in a file name, and as we'll see later in the script, we're passing in the elections.json file. The first thing we'll do is we'll open up whatever file gets passed in for reading and load the data as JSON. That means the elections variable is going to be a collection of Python objects like dictionaries and lists and strings, things like that. After we load in the election data, we'll define a variable named baseURL, which will have the beginning of the URL for all of the HTTP requests. All the polls within RCP start with that string, so we can only define it once and then append the individual resources we want to query to the end of it. Before we go further, let's explore the elections.json file. Again, this is what's going to get passed in to the getRCPAverages function. This file is a large nested dictionary. The topmost keys are the election names, like US President, US Senate, etc. The next level down identifies the locations. For the US presidency, both the national and state level polling is interesting to me. Each one has a separate URL, so we just need to identify the tail end to be appended to the base URL we just reviewed. Each election can be toggled off or on by setting enable to false or true respectively. In my experience, sometimes state-level polling can be very misleading or just low quality, so it can be useful to just disable those until there's a more trustworthy result. After collecting all the presidential-related polls, we can also define Senate polls in another dictionary. There's no national measurement as these are always statewide races. I've picked a few that I think are worth watching, with more to be added as the primaries end and candidates get solidified. There are other non-election related polls as well. For example, presidential and congressional approval, direction of the country, and generic congressional polls. The point of this file is to show you that no matter what kind of poll you want to check, they all work the same way and they fit into a common framework in a very simple JSON file. This means we don't have to update our Python source code every time we want to look at a new election. We can just update this file and rerun the script. Back in the polls file, the first thing we do is we iterate over each election. We don't care about the keys or the names of the elections quite yet, just the values. Each of those values is an election, which can be unpacked into a place, which is the key, and a race, which is the value. We're effectively iterating over every poll when we do this nested for loop. Before we do anything interesting, let's ensure the race is enabled. If it's not enabled, we should just continue to the next race and do nothing. Otherwise, if the race is enabled, we'll collect the poll data by concatenating the base URL and the specific race. Here's an example of what that final string might look like, and we'll pass it into the getPollData function that we imported from the RCP package. The result is a JSON structure that looks like this. If an RCP average exists, it will always be first. If you go to RCP's website as an example, this is always the case. However, if there is no RCP average, we shouldn't display the value. Sometimes if there's only 1 or 2 polls, computing an average isn't really useful, and displaying it could be misleading. In that case, the first poll would just be a random individual poll, and we'll update the race dictionary with 2 keys. We'll update it with the text key, which will just show that there wasn't an RCP average, and we'll add a color, which is just black, then we'll loop again. This way, the output will show that we tried to collect polls for a given race, but we couldn't find an average, so we just continue the loop. Otherwise, if we did see an RCP average at the top of the polls list, we should try to get the political party. I've written a helper function named getParty to abstract that logic. All this function does is it takes in an RCP average dictionary and determines the party, then returns it as a string. This would give us a string like parenthesis R parenthesis, parenthesis D parenthesis, etc. It would have been nice if this were an individually parsed field from the RCP package, but it simply isn't, so we'll have to do a little bit of work ourselves. First, we can index the spread key to figure out who the winner was. Typically, this will be an output that says something like Biden +4 or Trump +4 or whatever. Let's split that on the space character and grab the first element, which is going to be the candidate's last name. Once we have a winner, we can step over all the keys in the dictionary to figure out what party that politician is part of. That's because the dictionary has other keys that has the politician's last name followed by the party along with how they polled. Now, this script doesn't particularly care about how that person did, for example, 48 to 44%. We don't care about that. We only care about the spreads and the winners. However, we can use those keys because they contain the party at the end, so we can split that string and then slice off the last element. That will give us the party for whoever the winner is. We'll return that from the function. If we weren't able to find a party, we'll just return a parenthesis question mark parenthesis, which, if you remember, maps to the color of black. At this point, we have a valid value for the party. Let's declare some local variables for the spread and the date. The date gets trimmed to remove whitespace just to keep the web page more compact, which is really useful on mobile devices. Then we'll update the race, text, and color, kind of like we did earlier, except this time we'll actually display useful information. The text will display the place, party, spread, and date in one compact line. The color will depend on the winner, typically red or blue, and we'll use the color map to figure out what the color needs to be. After the loop ends, it can be useful to dump the updated JSON structure for visual validation. Here's an example of what that might look like, and I've included a detailed example in the data ref directory if you want to explore this JSON structure in depth. Next, we'll create a Jinja 2 environment. This is a text templater that integrates nicely with Python, and it works really well when you need to generate some text output with lots of variable substitution. We'll create the index.html file, the website homepage, using the index.j2 template. Let's declare a few local variables to make this a little bit easier. The updated variable is going to be a timestamp in a simple format that I think is a good fit for this project. Then we'll create a dictionary named J2Data. That dictionary has 2 keys. One is the elections, which is that big dictionary we just assembled, and the second is the updated key containing the timestamp. We can pass in this data into our template using the data keyword argument and setting it equal to the J2 dictionary we just defined. Calling the template.render function will allow us to get the HTML text back from the index.j2 template. Let's take a look at that template quickly. This is basically an HTML file with some Jinja 2 variable substitution and control blocks. There's a basic header at the beginning along with some commentary about the site. I link to the Real Clear Politics website, the source code, and my personal website. Next, we see a timestamp. We can access it by indexing the updated key within the data dictionary that we passed in. Then we have a pair of for loops that print all the data from the elections. The topmost loop prints a new H3 header with the election name, like US President 2020 as an example. Then the inner loop adds HTML list elements using li with the proper color and containing the proper text. That's basically it. It's a simple HTML site with a tiny bit of CSS for coloring. There's no JavaScript, as this project was designed to be fast, reliable, and simple. Back in the Python code, we just return the HTML text in case the caller wants to validate it. Lambda is going to use this in order to write a new file to S3 a little bit later. As a quick test, we can run polls.py as a standalone script just to see if our HTML renders. We'll load data from elections.json, which is the file we reviewed earlier, and just print the response to the shell. Let's run the polls.py script using the Python command shown. The script completed without any problems, but let's scroll up and look at some of the poll data. Now, we're not going to scrub all this in detail, but we can clearly see that the poll data is being displayed correctly. We see a mix of Biden and Trump winning in different places. We also see in one state, Minnesota specifically, that there wasn't an RCP average yet. We can also see that the timestamp is correct. Today is June 20th, and it's about 7:54 in the morning Eastern Time. I'm using UTC because people around the country and the world may be interested in this data. At the bottom, we can see other polls like the Senate races and other miscellaneous polls. Now at this point, we've just reviewed a standalone Python script, which is kind of useful by itself, but we should also review the code for Lambda. This time, we import Bodo3, which is the Python SDK within AWS. This is automatically available within Lambda, so we don't have to install it through pip. We also import polls, which is the module we just reviewed, which has the getRCPAverages function that we need to leverage here. The Lambda handler function is boilerplate, and we don't need these arguments, but I retained them just for consistency. If you use print messages within a Lambda function, that's useful for logging, so let's indicate the process has started. First, we'll use Bodo3 to get a reference to the S3 service, then collect poll data and render the HTML text. For logging, let's dump that HTML to the console so we can troubleshoot within Lambda if something fails. We could always take that HTML text and save it to a local file and then just open it with a web browser to see what it would look like once it's deployed. To copy the text to S3 as a file, we need to create a bytes object from that text. We'll encode it as UTF-8 so we can read it. Finally, we can leverage that S3 object by doing a put operation to add a new file to the bucket. This is just a wrapper for the REST-based S3 API, but it's a lot easier than manually making HTTP requests inside of Python. We specify the bucket name, the name of the file we are creating, the content type, which is text-based HTML, and the HTTP body, which is just the byte format of the HTML text. Once we complete that upload, we'll print a status message to indicate that everything worked. We can't run this file from here, but we can test it within Lambda. We'll do that in just a minute. I also want to mention the importance of continuous integration, which I have enabled using Travis. This is out of scope for this video, but it's always a good idea to automatically test your code when you make changes. The first step is installing packages, then we'll perform the linting and formatting checks, then we'll run the poll script. If it doesn't work here, it definitely won't work in Lambda, so this is a good way to help reduce risk and save you a little bit of money by having failed Lambda runs eat up a bunch of cost. Next, let's see how we set this up using Lambda inside the AWS console. Okay, we're in the AWS console, and I've already navigated to the Lambda service. Because this is my first Lambda project, I only have one function named polls. Let's click on it to explore the details. At the top, we can see the designer, which shows the different layers of the Lambda function, as well as other supporting services like CloudWatch. This is just a high-level view, so we're not going to focus there too much. Also, this isn't an AWS tutorial, so I'm not going to detail every mouse click and how to set everything up. There's plenty of those on the internet already. Let's scroll down to see the code that I uploaded. There's a section called function code, and you can see on the left that it's a pretty complicated project. I had to upload both the code that I wrote and all the PyPI packages I installed using pip. For example, we can see packages like RCP and Jinja2 here, and you also notice many other packages. That's because these two packages have dependencies, and we need to include all those as well. You can't use pip within Lambda, so you must include the packages in a zip file along with your code as a single upload. If I'm being honest, this is kind of annoying, and it feels like a hack, but it does work okay, and I suspect this is going to be improved in the future. I just downloaded the packages into my current directory, and here's a pip command that you can do that if you don't want to install them to the usual location. The reason this GUI is useful is that if your code fails, you can make direct edits right here to troubleshoot the problem. You don't have to keep rezipping and re-uploading your code every time you need to make a small change. I've created a test event named polls, which simply runs our code. It takes about 30 seconds to execute within Lambda. Right now it's about 7:08 in the morning Eastern Time on June 21st. That's 11:08 UTC. We can manually run this Lambda function by clicking the test button, so I'll do that quickly. We can see that the Lambda function ran successfully, and we can explore the details below. At the top, we can see some metadata about the run, including how long it took, how long I was billed for, how much memory was used, etc. At the bottom, we can see all of the output from the program. This is why I added those print statements to the Lambda function. For example, S3 upload started tells us that the script is running. Then we see the HTML dump of the output, again just for troubleshooting, and we can quickly explore that to make sure it shows all of our poll data. It shows 11:09 UTC, that's about right, that's 7:09 in the morning, and we can see a bunch of poll data which looks correct at a glance. Scrolling to the bottom, we can see our log message that said S3 upload complete. That's a good indication that S3 should have a new file with a new timestamp because we just ran the Lambda function again. In the next tab, I have S3 already open, so let's check the polls.njr USMC bucket to see if there's an index.html file. Because I had this tab preloaded, there's already a file there, and the timestamp is 2:16 a.m. Eastern Time. When I click refresh, we should see a new file with a timestamp of 7:09 a.m. Eastern Time. Let's do that quickly just to confirm that the Lambda function worked. Okay, this looks correct. We've got a 7:09 timestamp Eastern Time, just like we expected. In the next browser tab, I have the website open, so let's check that out too. This is what the final product looks like. Just like we saw from the HTML file, we have a little bit of basic context in the beginning, and then immediately we see all the poll data with some nice color coding. You can see the timestamp here says 6:36 UTC, which is about 2:30 in the morning Eastern Time, so if I refresh this page, we should see a new timestamp with 11:09 UTC. Okay, this looks good. We've got the new poll data as of about 5 minutes ago, and you can be guaranteed that this is the most up-to-date information. If you're wondering what this looks like on a smartphone, here's a picture of my personal phone from this morning. You can see the system time on my phone is 7:14 Eastern Time, which is roughly the same time that we ran our Lambda function. My phone is an iPhone 6, and on one screen length, I can fit all the polls related to the presidential and Senate elections. Hopefully you can see why this is valuable to have all this information in a compact format without 50 different mouse clicks to see it. Just remember there's no JavaScript and no advertisements, there's no autoplay videos, there's no clunky images. The other advantage of the simple site is that it consumes very little energy on your phone, which will help preserve the battery. You might be wondering, how does the automated update process work for this site? That's where CloudWatch comes into play, and I have that open in the next tab. I've already navigated to the CloudWatch rules section, and you can see that I have 3 rules defined. This one runs on a schedule, that's why it has a clock icon, where the other 2 are event-based. Those aren't related to this project, but if you go through my YouTube videos, you'll see where I explain those as they relate to doing continuous integration and continuous deployment for my website, and for sending me emails when my website is updated. Let's click the polls update rule to learn a little bit more about how it's set up. The schedule is fixed to 6-hour updates, and at the bottom, we can see the targets. The target is to run the Lambda function named polls, which we just reviewed, and of course this is going to update the website every time it runs. Last, let's talk about user access. How was I able to go to an S3 bucket using a DNS name? Let's check Route 53 for that, which is the AWS service for DNS. I've created a simple DNS mapping from polls.njr USMC to the S3 bucket of the corresponding name. This is easy and automatic, and this is how static websites work within AWS. It's just a simple hosting mechanism for static content. Towards the bottom, you'll see another record for www.njrusmc.net, which is my main site. This points to a different bucket, but the concept is the same. Let's quickly wrap things up. I encourage you to bookmark this site if you're interested and follow the election polls using it. I think it'll save you a lot of time and give you the information you need in a quick, easy way. If you've enjoyed my content, feel free to subscribe to the channel so you can get updates about when I create new projects. Thanks again for watching, and I hope to see you again soon. Take care.